Good evening, students. I welcome you all to the lecture of Advanced Microprocessor and Microcontroller. The lecture for today is to develop a art of programming. To start with a lecture on programming, I would like to deliberate few points or discuss few points with you people. As you are quite acquainted with the instruction set of 8086 and 8051, and these are the basic processor and microcontroller. Therefore, to develop a habit of making small programs should be easy at your level. So, I would like to take the basic foundation of programming. So when we talk about programming, the programming required no special skills. It required that the understanding should be developed about the problem. You need to develop the code instructions which are linked to the programming part. Then you have to visualize how the input and output can be given to the special instruction which are solving the problems, and how the output can be taken from the special instructions that are solving the problem. When you are able to diagnose the problem and you are able to develop the instructions which are linked to the core problem, you can easily plot a flowchart which will assist you in solving the programming part. So, to start with, let us take a small program in 8086. Suppose I am given with a list of numbers, list of words, list of numbers, list of bytes, list of bits, and I just want to calculate that how many numbers are even and how many numbers are odd. So the basic crux of this program is that I want to calculate number of even numbers, number of odd numbers. So first of all, I need to understand what is the intention of the examiner. Examiner want you people to calculate number of even numbers, number of odd numbers. So since this is a basic processor, 8086 a basic processor, so you need to understand what are the basic instructions that would link to your problem of calculating number of even numbers and number of odd numbers. So you have to apply flowchart. Flowchart is you have to take the numbers, you have to logically see the number by number, that it is even or odd. Then you have to take a counter, and you have to operate the counter in such a mechanism that till the counter is not equal to zero, each and every number is scrutinized to be found out as even or odd number, and then the program will conclude. So so that is the basic part and basic philosophy of programming. So let us take the logic. Suppose I am taking a even number, say 02, it is 0010. Clearly it is seen that the LSB part is 0 for 2, and for 3 the LSB part is 1. For 4 the LSB part is 0, and for 5 the LSB part is again 1. So it is quite significant that the LSB will decide that which number is even and which number is odd. If the LSB is 0, we can conclude the number is even. If the LSB is 1, we conclude that the number is odd. So, when we develop a program in 8086 for calculating number of even number and odd numbers, we need to understand that we have to take a command that is say rotate. So what is the rotate command? Rotate command just shift the byte as per your direction, and we can just place the LSB in a carry flag. If the carry flag is equal to 1, we can just conclude that the number is odd, and if it is 0, we conclude that this number is even. So it will all depend upon the rotate command. So let us take the program line by line by using assembler directives. We have discussed many programs in the lab, but if we want to write a program, say in a classroom or on a piece of paper, we have to use a assembler directive. There are many mechanisms by which you can use assembly directive. One of this is like this. Now we assume that CS is code segment, DS is data. Now the data segment consists of list of numbers. We develop a list, and we declare the words, define word, that is a directive. So these are the six numbers: 2357 0A579 06322 2457 00957 FE02. We take these numbers and we take the count. We decide the count with EQU, that is equal to 06. Now here the data ends. Now we take the code segment, that is the basic part of the program. So first of all, we need to take the value of BX, say to register, that is BX and DX equal to 0. The simple mechanism is to XOR any value with itself. Automatically that register will be equal to 0. So we are using XOR gate in order to ensure the value of BX and DX is equal to 0. Then we take a data in order to decide the location of data segment, that is ds comma x, that we do in a lab, that we clearly discuss and deliberate in lab why we are using these two lines. That is, we take a data in ax, and from ax we initialize the data segment. Then we take the value of count that we have already decided as eq as equal to 6. We take the count in as cl register. Now we take the first number. We take the first number in ax. We take the first number. Source index is pointing to the first number. Now this number, the location of the first number from where the data is taken to ax. Now we rotate the data to the right side by 1 bit. So when we rotate LSB by 1 bit, surely this part of the bit will be entered to LSB. This LSB will be a part of carry flag now. So if LSB is equal to 1, automatically the carry flag will reflect 1. And if carry flag is reflect equal to 1, automatically this number will be a odd number. So we take a carry here, we take a jump command here, that if jump if carry. Now if carry is developed, the number is odd, so we jump this number to a different location, that is odd, that is increment dx. So now the value of dx is equal to 0 1 if the number is odd, but if the carry flag is 0, this means the number is even. Therefore we increment bx, that is bx is for even register and dx is for odd register. Jump next, immediately we take the second number into account and decrement the counter, and this counter is rotated again and again till the value of counter becomes equal to 0. These are the two commands to exit the debugging of 8086. This is to end the code segment, and this is to close the program. So this is the basic mechanism by which you can write a small program in order to calculate the value of number of even numbers, number of odd numbers from a list. Now the value of dx in this case will be number of odd numbers, the value of bx will be number of even numbers. So this is a simple program in 8086. By using assembly directive, we can easily differentiate and calculate number of even numbers, number of odd numbers in a list. Similarly, I request you to kindly take up a small problem. Based on today's lecture, try to write a program to calculate number of positive numbers and number of negative numbers in a list of signed numbers. I thank you very much for listening to this video. Thank you very much. I want you to do your homework properly and just send me the program in the Google Classroom. Thank you very much.